All right. You can see from the title of my talk, I have a little different take on things. Is code ready for net zero, or is it a zero? And certainly, I am the Senior Scientist and Sustainability Principal for Beton Consulting Engineers out of home base is Minnesota, but I work out of Ohio. Certainly, we've seen we need to go to decarbonization. We've seen it as most recently in the June 2022 from Dr. Charles and I. We need to decarbonize. We're seeing it in the roadmaps, as we've talked about, and they're giving us some ideas of where we can go. Some of these are very achievable in the short term, and others are going to take a little time, like carbon capture, utilization, and storage. But certainly one of the things I focus on is if we look at the construction design of the buildings and optimizing concrete mixtures, and everyone's touched on over design, but I'm going to actually show you an example that might make it a little more clear to people why we can talk about it. Until you see the numbers, then you get shocked. And so we know why we have to do it. We are a very energy intensive group as far as looking at construction and so forth. But a lot of people, we've been doing this for a while. I've been doing sustainability since 2004. It's not new to me. It's I eat, breathe, and drink this every single day. And certainly why we've gone from the green buildings of long ago, we've gone to the sustainable buildings. Now we're at resilient buildings, and now we're talking about net zero. All have good portions to them. All have achievable portions. But not all of the time do we focus on the benefits of concrete within them. And certainly as we lower our reliance on the grid, our materials and how much embodied energy they give is going to be increasing, and so we need to be aware of that. Concrete, as it is a very low embodied energy product. If we look at it in comparison to our other main types of materials, such as wood and steel, we're very, very low. But we don't promote it well enough. And certainly when we talk about our environmental burdens, as much as we want to say we want to look at gate A1 through A3, we really need to look at the whole entire process. And when we look at that, we really need to look at what is my embodied carbon over the life cycle of the entire building or in the entire structure. And I can tell you, if we use adaptable structures over new structures, that payback period is anywhere between 10 and 80 years. So we need to look at more of other things like adaptation. How are we building? And while we can look at it in the codes, we also have to be able to adopt these types of systems. And waste generation is one of my pet peeves. Let's talk about it. If we have to take down a building that is only 20 years old because all of a sudden we don't like the way it looks, you just lost a lot of embodied energy for absolutely no reason at all. And there's nowhere to put this garbage and the waste that we produce. And talk about waste, we have to think about this consciously. Not only what we do, but what we do in the future. Certainly there are emerging approaches that are out there, and some of these strategies in sustainability in the design and construction industry are things that we've talked about, but things that we're not talking about readily, which are, strategies to increase resilience, passive building design, because we're going to see more rolling blackouts. And remember, our codes are not only here in the U.S., they are in other places in the world where they don't have the energy. They have rolling blackouts on a daily basis. Or what happens when our energy grid goes down? Look at Florida right now. Where's their energy right now? Down in Sanibel. Where's their energy right now in Fort Myers? How are they surviving in those homes? They're not. They're in a hotel at $350 a night. And it's a drain on that economy. We also have to look at design for disassembly and recovery. How many times do we take down a perfectly good column when we could have recycled it? Component harvesting. What about disassembly of buildings? There are new things going on across the world that we're just not willing to adopt yet because it's not invented here, we don't know enough about it, or we haven't studied it for 40 years, so we obviously can't adopt it yet. So we have to look at innovation. We need to adopt innovation, but we also have to look at our building codes a little bit differently. I look at them differently. And when we look at these kind of things, we have to look about how they impact our code as well. So certainly disaster resilience is the one I am going to harp on like no tomorrow. I lost people in this last hurricane, very good, dear friends. Why? Because their buildings didn't stand up. And why didn't they stand up? It's because the code didn't make them stand up. There's nothing more I can say about that. Most of the problems that we have in hazards today are not hurricanes. It's the flooding that comes after them. Because now if they're flooded, FEMA's going to come in and condemn them because you've had too much water in them. And guess what? They're uninhabitable because of mold. But guess what? Concrete doesn't mold, does it? The only bar that's left standing down in an area that I visited frequently is one that was designed above code and was on stilts and was prepared for the unintended consequences. When we look at the consequence of what happened in this hurricane, it's $67 billion. But more importantly, we have to look at the cost to society. How long is it going to take to rebuild that community? It's going to take decades. We look at what happened in the past, to the tsunami in Japan. That economy is not back. We look at Katrina, how many people lost their lives, lost their livelihoods, and they moved, all because there wasn't a good quality code, or the code wasn't adopted. We have to look at both in the ways that we look at it. So when we look at today's codes, yes, it's a life safety and collapse prevention code. But my problem is, yeah, I'll get you out of the building, but you're not coming back to a building. That's my issue that I have right now in the codes that we say are good quality codes. But there are other codes that are out there that say, look, we have to look at this a little bit differently. Now there are no regulations for ensuring that a structure will be usable after a disaster. But yet, UN's top priority is for resilience and hazard and being able to go back to your livelihoods and to your homes, and yet we have not actively adopted this. A lot of people say, well, I'm being a little harsh on the code. Well, we've seen changes to the code, and we know we will see changes in the upcoming code as well because we have a new subcommittee on this. But I don't think we're bringing strong enough. We're not mandating enough. Because the only way we're going to change the codes and change the way people build is to mandate it in the code. We look at what's happening at the International Building Code. They're looking to whole life carbon approach with whole building life cycle analysis. We're getting pushback about this. You know what? It's not about just gate A1 to A3. It's about the whole building. It's the only way that we can actively look at the benefits of concrete over the course of time. Why are we only having a building last 50 years or 75 years? That's absurd with concrete. We can build it for 200 or 300 years. Sure, there's maintenance cycles, but the cost to maintain is a lot less than the cost to rebuild, especially since you're only at a 50-year build cycle or a 75 build cycle. The code that I am looking at most reasonably right now, let me go back one. And again, here's the model code. The model code 2020, I'm sorry, I missed this slide, is really looking at things much differently. This is not out on the street yet, but I want you to start thinking about it. Because in my opinion, this is where we need to go. A structure is expected to be able to resist an extreme event with minimal damage. The structure should be able to rapidly recover its functionality. Doesn't mean I'm just going to egress. It means I'm coming back home. And that's what I think we really ultimately want when we look at a building code. We want to go back home. Those people in Florida don't have that opportunity right now. And it's not looking at just the small part of A1 through A3. We're looking at the entire process of the building cycle. We're also looking at what else happens. So when they're looking at risk, and I'm sorry my slides are skewing for some reason, what are the types of consequences associated with structural damage? Well, are we screening the risks appropriately? And some of these risks are slow onset risks. Some of them are large hazard risks. But are we designing for them appropriately? Are we using the right load schedules? I know ASCE is having a new load come out. But what about these slow onset of events of heat? Are we looking at thermal mass as a way to lower our operational energy as well as our embodied energy up front? Or for the passive survivability when the grid goes dark? Those are the things that I think about. Also, resilience is not new. We're very laggard in its adoption in all codes. Resilience has been out since 2011. This is 2022. It took us this long to think about resilience. I'm sorry, we have got to lead. We do not need to follow. Because if we don't lead, someone else is going to make our decisions for us. And do we really want that? That's my question. And we talk about EPDs, environmental product declarations, but if we really look at sustainability as a whole, which is people, profit, planet, we're also talking about people's health. And so you're going to see health product declarations come up as how healthy are the chemicals that you're using in the construction industry. And certainly talking about passive survivability. This comes from Minnesota, whereas if I'm off the grid, can I live there for 3 days until help gets to me? Or if I'm in a hurricane, can I live there 3 days without worrying about I'm not going to be able to survive? These are the things we should be thinking about because they are life safety issues, but they're beyond what we do today. And certainly there are ways to measure them and recovery methods to measure them, such as what is my percent functionality after the event? How long is it going to take me to get back to where I need to be? When talking about looking between the whole body, the whole life cycle, really when we look at how we can minimize our GHG or greenhouse gases, it's more than just going from, hey, I'm mining raw materials and oh boy, I'm building, let's not think about the rest. How do we place it? You know, that's part of ACI 301, and I know they just started a sustainability committee. It's talking about durability. We're making a durability code. Great. We're moving forward. But also, what about reuse? Are we really saying, okay, now we have to think more closely about reuse, and we shouldn't be just throwing those columns away? Can we make subtle frame buildings where they can come apart with dry joints? Or we have things like reciprocal frames, which have been around since Leonardo da Vinci. You can take a structure, take it apart, and move it. Where you're making parts that are very, very standardized and being able to use them over and over again in different types of structures. And certainly when we look at carbon payback, I said this. What about the reuse of the building with an average level of energy performance? If we look at the change, in some things, if we go to mixed use, depending upon the climate, it's anywhere between a 42-year and an 80-year over just rebuilding a building. Some things you'll never catch up with a warehouse to residential conversion, and there is really no difference. But are we also looking at those implications, as I said, on the slow onset of events? Are we prepared for temperature increases by looking at albedo and actually specifying a value or saying we've got to look differently? Look at the implications of climate change. It's not only just chloride attack, it's also abrasion, it's also scour, it's also other things structurally, mechanically, physically, chemically, biologically. And I'm going to harp on this one to death because I did do this exercise in the last, we have a paper coming out next, hopefully within this year. But the thing is when we over-design, someone touched on some of the things that, okay, self-assurance against failure. Of course, we're a litigious society in the United States. There's no doubt about it. And when you don't see a strength come up, the first thing that gets said is, oh my gosh, the concrete design is all wrong, or the strength isn't coming up in the cylinders. But really, where does the responsibility fall? And are we assigning responsibility to the players in the value chain of these kind of considerations? So there are over-design due to prescriptive specifications, compensation for water and other things, and placement times. Hey, yeah, add 50 more pounds. I don't want to keep my guys here any longer than I have to. I got to pay them more, and it's less to pay for another 100 pounds of cement than it is to keep 5 guys a little bit longer. But more so what we see is talked about the compensation for potential failures in testing or substandard testing. And we've talked about this, the required over-design of 1200 PSI. We've seen these kind of things, minimum compressive strength, maximum water-cement ratio. But here's where I want to bring it home. We know there's a 1200 PSI over-design. There's a lot of producers that simply do not have the number of people that they need on staff to do anything other than a 1200 PSI over-design. Or better yet, they really need that insurance policy because maybe they're very concerned of what's going to happen in the field. And we did a study in Pennsylvania, and it looked at a 4,000 PSI air and train concrete. We found out what the over-design was, which was 506 PSI. And then we also looked at what does that mean? Well, the over-design on average was almost 26%. And it matched really, really well. to what NRMCA has found in their statistical analysis over the last, from 2012 to 2020. But what does that mean in carbon?
What does it really mean? When we look at
that really conservative value of overdesign, it's almost 28.7 pounds per cubic yard. Now, this was with almost 15% SCMs in this mixture. But if you look at that, it equates to 4.4 million metric tons of cement.
I'm in a cement shortage right now. If I had those 4.4 million metric tons, I wouldn't be on allocation and not be able to supply my projects.
But more so, if we look at the 1200 PSI prescriptive overdesign, we're almost at 50 pounds over what we need in a concrete mixture. And that equates to 7 million metric tons of cement in overdesign. And that was just in 2020. That was almost 7% of the amount of tonnage that was used in the entire year. Think about that. Overdesign. It all sounds good when we just talk about it, but when you look at the numbers, it's really detrimental. And so there are other things, as I said, there's materials, there's construction, we need to look at clean energy, we need to look at reuse, we need to look at end of life and how we can look at these things actively. These are the ways that we can reduce our carbon footprint. And so I'm not going to close with much more, except that the materials we choose have an impact. And we have to understand that every time we select a material, it's not just the environmental impact. Quit thinking just about the environment. Start thinking about other economic indicators. Start thinking about social indicators. And quit thinking only about CO2. You know, there's other resources that are wasted here. What about water? Because I'm guaranteeing you right now, there's people in this world that aren't too concerned about CO2, but they're a whole lot concerned about where their next water is going to come from. Look at Lake Mead. Think about the draws that come from ready-mix production and the production of concrete. It's much higher than you think. And yes, I know it's a balance, but we need to start thinking about it more rapidly. Otherwise, we're never going to get to carbon net zero.